Hello, you are most welcome. I'm Teacher Ivan from Wuuna Educational Services. I welcome you to our second lesson of vectors. We are still looking at O-level vectors, and in our previous video we've just covered addition and subtraction of vectors, where we also looked at how we multiply a vector by a scalar. So please, if at all you missed out that, please go to our playlist, go to O-level mathematics and watch, so that we move together as we enjoy together. This is our second lesson, where we shall be looking at the magnitude of a vector. Yes, the magnitude of a column vector is simply its length. And this can also be termed to as the modulus, which means the positive square root of a number. So magnitude is also the same as modulus. Now, this is how we get the magnitude of a vector. We are told that assume that A is a point with a column vector xy. And this is our point A at xy, meaning that it has been displaced through y values vertically and through x horizontally. And therefore, if we are to find its magnitude, then we have the horizontal displacement from the origin and the y displacement. And therefore, this gives us a right-angled triangle whose hypotenuse represents the magnitude or the modulus of vector A. And therefore, we are to find the magnitude of vector A, which is also the same as the hypotenuse. So we shall borrow a leaf from the Pythagoras theorem, which states that A squared plus B squared equals to C squared. So in this case, we have OA squared equals to OB squared plus BA squared, where OA is the modulus or the magnitude we are looking for. And therefore, OA squared equals to OB squared, but OB is x and the BA is y. So when we substitute, we come up with the modulus of A being the square root of x squared plus y squared, where the modulus is the magnitude of vector A. So that is how we get the magnitude of a vector. Now let us look at examples. We have example 1, which says that given that vector P equals to 3, 1, vector 2 equals to negative 1, 2, and R equals to 4, 3, then they want us to find the magnitude of P, magnitude of 2, magnitude of R, and then magnitude of P minus 2, magnitude of P plus 3R, and so on. So this is how it is done. They want us to find the magnitude of P, but we've derived the formula for magnitude, which was x squared plus y squared. And now P, the positioning vector of P is 3, 1. The first one shows x, the next one shows y coordinate. And therefore, it's a matter of just substituting in the formula for magnitude. So that is magnitude of P is given by the square root of 3 squared plus 1 squared, which gives us the square root of 10. So that means that root 10 units. You must always include that word units. meaning that you are moving through these units to reach where P is. So that is how we shall get the magnitude of P. So we come back to our question. Your task is to get the magnitude of Q and R. Then for us to get P minus Q, we first subtract. Let us try that together. So they are asking for the magnitude of P minus Q. You're trying Roman numeral 2 and 3 because we've seen how we did in A or in 1. So the magnitude of P minus Q is given first of all by first subtracting P minus Q. We saw how we subtract in our first lesson, whereby we saw that when subtracting or adding, we add or subtract corresponding components of the vectors. So that is P is 3, 1 minus Q, which is negative 1, 2. So once we subtract, we end up with 3 minus 1 and 1 minus 2, which gives us 4, negative 1. So that is P minus Q. And then its magnitude, the magnitude of P minus Q will be the square root of 4 squared plus negative 1 squared. The square of a negative is always put in the brackets, because once you don't include brackets, that means that you are getting negative of 1 squared, which becomes negative 1. So that gives us, this is root 17 units. That is how we deal with the magnitude. And now when we come back to the question, please, you're trying out the rest. You're trying out the rest. That is for our perfection. You try out and you may also comment with your solutions. Otherwise, there is also a second number for us to try out, which says that if the vectors R equals to that, P equals to that, then they want us to find the length of a half P plus R. That is also yours to try out. Please, always try out these numbers such that your practice will improve your perfection and will also approve the acquisition of the knowledge. Otherwise, I'm Teacher Ivan, and I request to pause from here for this lesson. Otherwise, please subscribe and hit the notification bell such that whenever we have a lesson, please, you are not left out. We learn together as we enjoy together. Otherwise, I expect you to try out and comment with your answers, or else you can also always ask different questions or request for different topics in our comments. We shall always read the comments and respond as early as possible. Otherwise, see you in the next lesson. Bye bye.